All right, developers, more about strings. There's a lot to talk about strings. Strings, we can learn a lot from strings. So here I am going to open up a file underneath the 03 strings folder. The first file in there that currently is number 10-strings. Let me close this little explorer and I'm going to go spin up my live server. And we're going to look at strings in the browser and we'll look at strings in VS Code. All right, so here we are. We've talked a lot about strings. We're going to talk some more about strings. Now a little new dimension about strings. Let us talk about strings not as a string, but as an array of characters. Okay, so every string in every programming language that I've worked with is essentially an array of characters. So what does it mean to be an array of characters? We're going to learn a lot more about arrays later on. I'm going to give you, this is our first little preview of what an array is. And it's good to talk about it in the context of a string because strings definitely, there should be no bite. There should be no intimidation on what a string is at this point that we've talked about it so much. Let's talk about a short message as opposed to this longer message. So here's a short message. We refer to this as a string. Hi, H-I, exclamation mark. So in the context of, hey, this is a character array, what does it mean to be an array of characters? An array, you can think about it as a collection or a list, right? A collection or list of characters. That's English now. Very careful because in some languages, when someone says a collection or when someone says a list, that's specifically that's actually two examples of data structures. An array is actually an example of a data structure. And so in English, it's just a collection. It's a list of letters. H-I exclamation mark, right? And so the first, if you and I were speaking in English, we would say that the first character, car, C-H-R, right? So when we talk about an array of characters, you're going to see, let me write this out, car. Right, car, an array of characters. So the first member of this array that I've written out so that we can talk about it on the screen here is H. The second one is I, and then the third one is this exclamation mark, okay? Now, really interesting, when we talk about arrays, and a lot of times when we talk about a position of something, in a programmatic terms, the position of one thing relative to the list itself, right? Like H, here's first, I is second, and the third character is the exclamation mark. Oftentimes, well, pretty much almost every time, we don't actually say H is first, right? So if I was going to write this in numeric format, would I say 1, 2, and 3? Right, now notice I can't name a variable by starting with a number. So this, in English, we would say this is the first letter. Programmatically, though, we don't refer to H as the first letter by number 1. We talk about its position as being 0. Then the next one, actually, let's just use position 1, and then position 2. Oh, I put a little guy there that's not supposed to be there. So this is how we actually refer to elements, members of an array. We refer to them by their position, and we do so in what is referred to as a zero-based index. So H is the first letter of the string hi, and it's in position or index 0. For example, let me illustrate this. Now, programmatically, how would we express that? We say, hey, here's the short message. I hit enter. And then there's hi, right? So let me scroll this a little bit better. So there's hi. All right, let me write this down. All right. But now, new notation. I'm going to introduce you to something that is called using brackets, using bracket notation. So here's my short message. But I want to access just one character of this array. When you see these square brackets, oftentimes, if they're dealing with an array or a string, In fact, when they're dealing with an array, you like probably we're dealing with an array here if you see these square brackets. Sometimes in other data structures like a dictionary, it might mean something else. But oftentimes the number then you put here, if you can put a number here, it's the position. So you'll notice here that's short message 0. I hit the up arrow, short message 1, hit the up arrow, and go all the way to 2. Okay? So if I go all the way to 2, by the way, if I go to 3, I get undefined because there's nothing there, right? There's nothing there. So one more time, let's see that in play. We're going to say short message 0. The position of 0 is the H. The position of 1 is the I, and the position of 2, index 2, is the exclamation mark. Together, they say hi. They're really happy about it. Hi, exclamation mark. And by the way, instead of using the bracket notation, I'm going to use dot notation and access a property of the string object. All string objects have a property called length. Length tells us how many characters are in the array. The character array. How many characters are in the string? Okay, and so this is true even if I were to take, let's say, see this entire string. If I say message dot length, I see I get 33 because I get 33 characters. If I say message square bracket 0, now 0, think about this now, a pop quiz. If I say 0, am I going to get a space or am I going to get a T? And the answer is I'm going to get a space because the space is actually a character, right? It's not a visible character, but it's still a character. So if I wanted to get that first T, I have to go to message square bracket 1. So really important, start thinking about this array of characters, aka a string. Start thinking about the string. Think about a string as an array of characters, okay? That we can access each individual character by index. And then this is going to be very helpful later on when you start trying to learn a little bit more about arrays. So the other thing I want to, now we have a number of things to cover. I just did the length, right? So I did the message dot length. And look, when you're in here playing, like let me say up arrow, I wanted to say, hey, dot length. I could even do a dot length on a character. Okay. Trim. So let's take message that has this white space built into it. Okay. I'm going to take message and I'm going to use this function called trim. Trim is a function. Okay. So if I simply say space enter, I get this little funky feedback. The output from the console doesn't seem too friendly. But what I want to do is not simply reference the function. A function you must execute kind of like the console.log, open close parens. And when you execute message.trim, what you see is that you get back a string that has no spaces in it. Now, however, let's look at this. You'll see that the message itself is unchanged. So this is actually a behavior that you're going to begin to understand, especially when you get into, if you start working with a library called React. The string here is what is referred to as immutable. A string does not change. And so what this does is that actually doesn't change it. It leaves it in place. What the trim function does is that it takes the existing string, in this case, message, and it essentially processes it, and it takes out the white space from the beginning and the end, and it gives you back a new string. Okay? And so it's this new string that if I were to say up arrow dot length, I would get back a 31, as opposed to a message dot length that gives me a 33. Okay, because the message still contains those extra 2 spaces that were at the beginning and the end, right? And if I were to change this message, right? Let's do this over here. Message dot trim, right? So I'm going to trim this before the graph tool has a chance to draw it, but notice because it hasn't actually, it doesn't change the string that it does the operation on, right? It doesn't change that string. For me to actually visualize that, I would need to and actually change now message. I'm doing message equals message.trim. Okay. Now, real interesting. What's going on here? Let me draw this out for you because this is important. When this message is first created, right? When this message, here's this variable, when it's first created, it's actually pointing to the string that has the spaces in there before the T and has all these characters, and then it ends with this white space at the end. That message variable, again, thinking back to the very first video in this course, this message variable is a pointer. And somewhere in memory, for a very short period of time, the string that actually has the little spaces here is still around, right? So that message with those extra little spaces is still around. But what happens is that when we do this operation, we take this pointer and actually say, hey, no, we're going to point it at a new string, right? And it happens to be the string with these two particular characters. Let me try and let me get in here. Our new message, we call it trimmed. Trim message is equal to, and I want to get this guy right here. I'm going to leave message alone. I don't want to change message. And then finally, actually, then I'm going to take message and point it at trim message, because this is going to show me a little bit more. It's going to draw for me something that's a little bit closer to what actually happens. Oh, there's my message. Where's my trim message? There's my trim message. My message. This is the tough thing with strings. The guy with the spaces is no longer because of this particular operation. Okay. So I'm going to use a function that I have in here to help me with this particular problem. Let's see if my little function is going to work. Okay. So here's what happened. Notice how in the graph there are these two big areas. This is picture one, and then this is picture two. This is essentially the before and after. Okay, that's what we have going on there. So what happened? We started out with this original message, right? With this same variable. This variable is the same as this variable. Okay? Those variables are the same. Now, what happened was that at the beginning, this variable pointed to this particular value in memory. This is an array of characters with spaces at the end. And so this guy here, this value is actually hanging around in memory right now. And the first time that we rendered this graph here, the variable pointed to this area in memory. When we conducted this operation over here, what we did was that we took message and we pointed it at the value that we see here in memory. Let me do that with the same color. We took this variable, message, which is the same variable here, and we changed the pointer to, instead of pointing at this particular string object, we said this variable is going to point at this particular string object, which is located here in memory. So for a split second, actually, this value in memory hangs around a little bit because that's just the nature of memory. Later on, there's going to be a process that comes by and cleans it up, but it stays around for a second in memory. And a new allocation of memory without the spaces, a new character array, a new string gets generated. It got generated here, right? And we ended up pointing it to it, boom, right here at the bottom on line 35. All right. So all this is to understand a little bit about how strings work and how these pointers work. All right. That even though we did an operation like trim.message is equal to message.trim, it feels like we're pointing back to ourselves, but we're assigning a value to ourselves, because sometimes, right, in our minds, if you think about variables as actually being the ones that hold value, it feels weird to say x is equal to x dot execute some function, right? So in this case, it feels weird to say message equals trim.message. That feels a little weird because it feels like you're kind of like pointing at yourself. But underneath, there's a lot going on. Underneath, what happens is that this is a pointer. And at first, this pointer is pointing to this memory. And then later on, this pointer is pointing to a new area in memory. Okay? This behavior and this example of having something in our code that says message equals message.trim, where you seemingly are changing, right? Where we are seemingly changing the value of ourselves to something else, feels a little weird. But it is very much saying that I have a variable called message, and this variable called message at one point pointed to an area in memory, and this line is simply saying point to a new area in memory, right? To a new address in memory. Okay, let's continue to dig down into the other aspects and the other functions that I want to talk about in strings. Control-Shift-I in my developer tools to bring up my console. So we talked about the trim. It takes the white space off the beginning and the end. The length gives me the length of the array. Ooh, let's talk about indexOf. So indexOf. So for example, indexOf. So if I say message, indexOf is a function. There's a lot. Notice, look, there's a lot attached to this. There's a lot of functions. There's a lot of properties. There's a bunch of different things attached to this object that's simply a string. I'm going to execute an indexOf. So I want to search. For a T, right? In fact, no, let me search for a T because I know the T there. I know there happens to be a capital T and it's at index 0, right? So what indexOf is, it tells me the index, the first index, because if I went to look for example, A, right? A, the first index of A is located here, right? Right? And I can test that. If I really wanted to test that, let me see if I did the index. If the first instance of the letter A is in position A, then if I went down one character to 7, I should have an empty space. Okay? And then naturally you can just count up to 8 right there. So indexOf finds the first instance, right? The first instance of that letter. Now, what if I did capital A? Notice now, because there is no capital A in here, so look, it's case sensitive, it gives me back a -1. -1 is the flag that we would use to say that we would programmatically write some code and say, hey, if the indexOf is -1, it means that this string does not exist in this other string. And now it doesn't have to be limited to a character. We can put an actual string in here. So if I wanted to say and, that works. If I say and, that doesn't work. If I say and with a space and a space in front of it, that works. It's in position 7. So notice the position 7, it tells me the start of, so and is found right here, all right? So indexOf is a really nice way to find a string within another string. The other thing is, if you notice, if we use the power, what I refer to as the power of IntelliSense here, I actually have an opportunity to pass it two arguments. First A, and then at the start position. What if I wanted to start at 10? If I wanted to start at 10, right, so the position 10, so if this is 8, this is 9, this is 10, then it tells me that the A is the next immediate character, right? So I could also, what I'm doing here by providing this second value is saying, Or actually, technically, if I say this, that is the equivalent of saying this. In that, if I don't provide a starting position, right, at which point in the string am I going to start looking? This says I'm going to start at position 0, so basically at the start. When I said 10 here, I said don't start looking for the letter A until you get to basically this white space. It just so happened that it immediately found the A in the next character. So there is a, again, there are a ton of different functions in here. Go ahead and use the resources that we've used, that we've put next to this video, so that you can go and play around with some of them yourself. Because I can't go over all of them. I'm gonna go over with some of the more important ones. Well, that's not even fair. Some of the ones that you might end up using in this course and in the following course. So we did index of what starts with. So starts with. So what starts with does is that it looks at the string and it tells us, right? And I'm going to put this up here because this yields another expression, right? So var, let's say if it starts with, I'm going to just say is, I can't come up, is important. For some reason, I think that if a message starts with the word this, that it's important. Okay? So if the message starts with this, right, starts with yields a Boolean, right? Let's combine a little bit about what we learned in other videos. Let's say type of. What is the type of is important? And it's a Boolean, right? Is important is true. Is important is it equal to true? It is, right? It just so happens that the strict comparison as well as the not strict comparison is going to work here for true. Okay, so starts with is really cool. Another one that is really comes in handy because, let me get this out here. Lcase for lowercase, and if I have my message to lowercase. By the way, these functions start with trim, pretty much just about every function that you're going to work with here in JavaScript. There's going to be a variation of it, if not exact copy of it in pretty much every programming language that you work with. So toLowerCase takes the string and basically gives me the lowercase representation of it. This is an array of characters. Let's say this is an array of probably 33 characters. In case you were curious, what does it do with a number? Well, it doesn't do anything with a number. It doesn't do anything with the dots because there's no lowercase version of a number. So it just gives us that. Now, what the lowercase and uppercase is really important because every now and then, and this happens more often and quicker, faster than you would think, you end up comparing string A to string B. Okay? And for example, here's the problem. If you say is message equal to Lcase. Let's see if message is equal to Lcase. And if you're playing along at home, you're going to see that false. They are not equal. So at first, you might not catch, why are these things not equal? What's the problem? Because essentially there's one character in here that's lowercase and another character that's uppercase. So inevitably, when you end up having to do this, and more often than not, it's because you're taking input from a user, right? There's a user that's in there typing their first name, that's typing some type of message, and you're trying to take that message and compare it to something else, something that you have in your system that might as well been generated from a computer or from another human being. If you really kind of want to find out if they type the same thing, more often than not, you don't really care about the casing. Sometimes you do, but more often than not, you really don't care about the casing. And so what you end up doing is that before you do any kind of comparison like we have here, you are going to want to make sure that both instances are lowercase before you try to do a comparison, because your probable intent is not to care about casing. So you're going to want to end up lowercasing both of your strings to do the comparison. All right. So let's move on now to something a little bit more. Okay, slice. Extracts a part of a string and returns a new string. Ooh. So what's that? And it's very similar to some of the topics that we discussed here. Let me write out message, and in message I want to slice it. And I say, you know what? I want to start at character 5. Actually, let's verify what's at character 5. Character 5 is I for the is. All right, so I want to start at character 4. So I'm going to slice it, and I'm only going to provide one. I have to provide the start. Well, if I don't do anything, what happens? It just gives me back everything. But if I give it one character, what it does is that it takes the entire string, right? And actually, let's see if it takes the entire string. Does it change it? It doesn't change the original string. So again, it doesn't change the original string. It simply starts at the index of 5, and it takes everything to the right, all the way to the end. So slice says, hey, 5 and all the way to the end, give me a new string. There it is. Now, what if I only wanted, come back in here, click up arrow, say I only wanted the first five characters. Oh, 5 and, so I have to go to the end. I have to give it an index. So let's just say I go to 10. This as an, right? So I picked up the next 5 characters. Notice it says that the end is not the, like how many. Sometimes and I got burned a little bit right now. Sometimes the second argument, depending on your programming language, it doesn't tell you the end index. It tells you how many characters you want. I thought this was telling me how many characters that I want, and that's not the case. Here, it wants you tell me what index to stop, so it's going to stop at index 10. Now, if I went big and I went to 50, again, it's only going to pick up however many characters that I want. So that's the slice. It gives you a slice of the string that you're working off of. Now, the last one is really important, and let's put this out here because now I want to demonstrate this as parts. And I'm going to take my message and I'm going to split it on an empty string. And so what this is going to illustrate for us is our first representation of an array, and this is now an array of strings. So a little confusing. A string is an array of characters, sure, but notice, a string is just, we know that we want to render a string in this manner, so it renders the string in this manner. But this is an array of characters. Here now, parts is an array of strings, okay? And again, naturally, every string is an array of characters, so a little confusing. But in this array of strings, how did we get here? We used a split on an empty space. So what the split does is that it takes every one of these words, and as soon as it finds an empty space, it basically says, look, this guy's going to be an array member, not the space. This guy's going to be a next member. This guy's going to be another member. Array is going to be another member. Of is going to be a member. 33 is going to be a member. And then characters is going to be another member with the dot. Okay? So now this is an array of strings. Again, you notice the object graph. You're going to notice that the object graph uses the square brackets to denote an array, which is a little different than actually very different than how it represents a string. But like the string array, if I'm dealing with an array, notice how in the console it looks a little different. You hit up arrow. Like an array of strings, if I want to reference the first element in this array, I use a zero-based index. The zero-based index, I want to go to this. There it is. Enter. Okay. If I want to go to the second word, I go to index position 1. And if I want to go to the third word, I go to index position 2. Right? just like a string. Let me hit clear. And just like a string, I can say dot length. I can type dot length using dot notation, dot length, to access a property of an array. And boom, I get the length. I got 7, right? So there's number 7. I got the length of the array. And if this says 7, it means that the last member of the array, the last slot of the array, is number 6. Okay, this has just been a preview of the array. We're going to talk more and more in depth about an array in another video. I wanted to draw the similarities between a string and the behaviors of a string, which is a character array, to a vanilla array, an array of strings. Okay, and we naturally are going to have an array of objects. We're going to have an array of numbers. We're going to have an array of anything we want. And so stay tuned for more, even yet more, on strings.